see about direct form to realization. Is continuous time and discrete time system. Direct form to realization. It is the direct implementation of transfer function describing the system instead of using separate unit delay elements of input and output variable separately. An intermediate variable is the unit delay element. It provides direct relationship between the time domain and z domain equations. And the advantages: it uses minimum number of unit delay element, straightforward realization. Here, since it is in the case of cascade arrangement, the order of the system is not important. Therefore, all the pole system H2 of Z and all the zeros H2 of H1 of Z can be interchanged in the case of direct form to realization. Let us take the transfer. Here we are using an intermediate function v of z. H1 of z equal to v of z by x of z, which is given by 1 by 1 plus summation k equal to 1 to n a k into z bar minus k. And here we are converting this in terms of time domain equation, and this equation shows the time domain form of this given above equation. And also we are splitting the second equation to h1 of z equal to y of z by v of z equal to summation of bk into z bar minus k, and the time domain for this equation can be given by this equation, that is y of n equal to b naught v of n up to bm v of n minus m. Both the time domain equation involve the delay version of v of n, and hence it requires a single set of delay elements, and this result in the direct form to structures. Direct form to realization. Here in this direct form to realization, the difference between the direct form 1 and direct form 2 is, in the case of direct form 1, we are realizing the denominator, the poles, and next we are realizing the zeros. But here we are just changing the order, interchanging the order of poles and zeros, and then we are connecting this, and finally we are obtaining the direct form to realization. In the direct form to realization, first we are realizing the poles, and next we are realizing the zeros. Therefore, at first we are using the summers, and in between this poles and zeros we are using the delay element, that is z bar minus 1. Therefore, this is the final structure of direct form to realization. It is otherwise said to be series form. In cascade form realization, in the given transfer function is expressed as the product of several transfer functions, and each of this transfer function is realized in direct form 2, and then all those realized structures are cascaded, that is, it is connected in series. Let us consider the system with the following system function. Let us take h of z equal to, that is, multiplication of two or more systems, that is h1 of z. We are dividing in the cascade form realization, we are dividing the whole transfer function into smaller subdomains, and also we are dividing in such a way that the order of the numerator must be equal to or greater than the order of the denominator. Therefore, here we are dividing this into two system functions, h1 of z and h2 of z, and finally this h1 of z and h2 of z are realized by using direct form 2, and finally we are connecting this direct form 2 structure. Therefore, we are getting the cascade form, that is, this is h1 of z and this is h2 of z. Here each h1 of z and each transfer function h1 of z and h2 of z are realized by using direct form 2, and finally we are connecting this 2, and therefore we are finally getting the cascade form realization. Next one is parallel form realization. The given transfer function is expressed into its partial fraction, and each factor is realized in direct form 2, and all those realized structures are connected in parallel as it is shown in figure. And here let us consider the following system with the following system function, that is h of z equal to c plus summation k equal to 1 to n ck 1 minus pk into z bar minus 1, where this pk are the poles and ck are the coefficients, and here we are applying different values for k, and finally we are getting the system function as h of z. And here also this numerator, that is, each system function we are realizing by using direct form 2, and here the numerator must be, the order of the numerator must be less than the order of the denominator. Now we can see the structures for parallel form. Here each system function is realized by using direct form 2, and finally we are giving a single input, and the output are given to the summer, and it result in the parallel form realization. And these are the quiz question that is available in this block, that is possible quiz question in the block diagram representation. Thanking you.